All right, ladies and gentlemen, welcome to section 5.3 financial algebra. This is graph frequency distribution. Let's hop into the vocabulary. First vocabulary word we have here is frequency. Now this is the relative number of times something occurs in a given sample. So we're going to see a couple data samples, and maybe we have an item priced at $5. How often was that thing purchased? That would be the frequency that we're looking for. Next word is box and whiskers. Now this is a special type of diagram showing quartiles 1, 2, and 3 in boxes. So we're breaking up the data into 4 sections. So we got a box, and then we have 2 lines sticking out of each side of the box. One line will extend to the lowest number on our data sample. The other line will extend to the highest value in the data sample, and this will be a box and whiskers. All right, let's jump into the practice problems. This is practice problem number 1. So Jerry wants to purchase a car stereo. He found 33 ads. He's analyzing the prices, but he's having trouble because there's so many numbers. How can he organize his prices in a helpful format? So, I mean, there's a ton of different numbers here. And rather than looking at some things, let's just kind of sort this out logically. So I'm going to sort this out by hundreds. So if the price, we're going to make X the price. What if I looked at some of the prices that are greater than or equal to $500, but less than $600? How many of those do we have? So if I looked at this table here, I got 1, 2, 3, 4, 5. They're already in ascending order. So I got 5 of them that fit that criteria. What if we picked another one? What if we said, you know what? I want the price of this stereo to be greater than or equal to $600, but it's got to be less than $700. Maybe that's my price range. I'm going to spend between $600 and $700 on this car stereo. Well, I can look at these 1, 2, 3, 4 of them. So I have 4 different stereos that I can choose from. Let's pick another color. Okay, so let's say we wanted the price of this thing to be greater than or equal to $700, but no more than $800. Right, it's got to be less than $800. That's my price range for this car that I'm working on. Okay, cool. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different stereos are listed at that price range. So I got 10 different stereos. What if I had a bigger budget? What if my budget was, what if my price budget was greater than or equal to $800, but I couldn't spend, it's got to be less than $900. Well, if that's the case here, 1, 2 stereos fit my criteria. And then if I'm just a baller on a budget here, I got a baller budget. The price of my stereo can be, you know what? I'm going to spend something around $900, but I'm going to spend, let's go with less than, what's the max here? Less than $1,500. That's the most I'm going to spend on this stereo. So if I had that price range, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that's the rest of them. So how you organize the data to kind of look at the frequency in this ad, now you have a budget that you can kind of be realistic. And on the last one, I just kind of spread it out between $900 and $1,500, but you could have done it from $900 to $1,000. You could have broken this up, you know, anything over $500 or less than $800, whatever you wanted to do. But now you've broken the data up into pieces that are a little more manageable than looking at a bunch of numbers. Alright, so example number 2 here. Find the mean of the car stereo prices. So mean is we add up all the numbers in the data sample and then we divide by the number that there are. So this is actually a frequency table. So what it's saying here on the frequency table is if I take a look here, if I take a look here on our frequency table right here, what this is telling me is, that's a horrible arrow, but what this is telling me right here is that the price $540, there is one stereo here at $540. If I look at this stereo price right here, for example, the price of $700, there's 7 different stereos that I can choose from. And the third column here is the price times the number of times it shows up. So literally it's already being added for us. So 700 times 7 is going to be that $449, or sorry, that $4,900. So we're already multiplying out the number of times it shows up. These product totals here in this section, in this product PF section, they're already being added for us. So if we take that entire column and we look at the bottom piece right here, this is all the data samples added up, every single car stereo price added together. And the number of times it shows up, if I add up that column, the total down here says there's 33 different car stereos that I can choose from. So to find the mean, all I got to do is take this average piece right here. I'm going to use a different color. Take this average piece right here, divided by the number of data samples here, and we should be good to go. So this is going to be $26,425 divided by the 33 different stereos. That should be $800 and about 76 cents approximately. That is the mean that we're looking for. All right, example number 3, find the interquartile range of the data. So a couple things that I want to do before we find the interquartile range is I want to label some of these things on this box and whiskers plot. This represents the minimum number in the data sample. This number over here represents the maximum number in the data sample. Now everything in between, this right here is the median, so I'm going to write median right here. But it is also, actually, you know what? I'm going to write the median up here, median. But it is also Q2. This guy up here is the upper quartile, also known as Q3, and this one over here is the lower quartile, also known as Q1. So once we have identified all the pieces in this box and whiskers, then I can figure out what the interquartile range is. So I'm still looking for range in this example. It's still asking me for the range. Range is the oops, doesn't want to go. It's all right. Range is the difference between the maximum number and the minimum number, but we're looking for the interquartile range. So we're just going to be focusing our attention here on Q1 and Q3. Okay, so the interquartile range is going to be Q3 minus Q1. That's going to be the interquartile range. And if we look at the variables here, the numbers for those variables, this is going to be 55 minus 23, right? And so the range within these quartiles, what happens between this point right here and this point right here, the range of those data samples is 22. That is what we call the IQR, or interquartile range. All right, last example. The following box and whiskers plot gives the purchase price of the cars of 114 seniors at West High School. Probably should have changed that to East Lake High School, but that's fine. Are there any car prices that are outliers? Well, in this case, let's look at the data. We have a minimum value, right? Let's write. Let's put some color in here. So we have a minimum value right here. The minimum value is that $3,000, right? Can't write minimum. And then we have our Q1 right here at 52,000. We have our Q2 here at 7,000. We have our Q3 here at 9,100, and then all the way out here we have this max price. Now that is obviously a very long whisker here. What does that tell us, right? What we got to remember is that each quartile range represents 25% of the data points. So 25% of the data points, 25% of the 114 cars selected were between $3,000 and $5,000 of a purchase price. 25% of the value, right? 25% of the 114 that were picked would be in this Q1 section right here. 25% of them cost between $5,200 and $7,000. So there's 25% of the data over here in this maximum section, this big long whisker, between $9,100 and $43,000. But obviously this $43,000 over here, that's pretty much an outlier. Chances are there's maybe a couple different cars that at most have that value in a senior class, right? So what we can do here is, first of all, the question's simply asking us, are there any car price outliers? And we can look at the data and we can easily see that this price right here is definitely an outlier. But I'm going to do something a little bit different. What if we created what's called a modified box plot? Okay, so a modified box plot. Boop. I'm going to create one right there. So what we're saying here is, you know what, most of those other data points, because remember what we said originally, right? We said 25% of the data, and I'm going to pick a purple here. 25% of the data is right here along this line. This is 25% of the data selected, right? 25% of the data selected was between 9,100 and 43,000. But it's kind of, you know, what we're saying here now is check out this big empty gap right here. There are probably 0 cars in our data sample that are between 12,500 and 43,000. There's this one outlier here on the end, and everything else, the other 25%, most of the data lies between 9,100 and 12,500. So if I was to look at the data sample, this last range right here, 25% of the 114 cars that we pulled out are going to have a price between 9,100 and 12,500. That makes more sense. So we can identify the outlier there a little bit easier. And this is what we call a modified box plot. So we still have the box and whiskers here. It still has, you know, the minimum, Q1, Q2, Q3, and the maximum, but we shorten the whisker and just account for that 43,000 outlier point there, just to show us that, you know, the data is mostly within this space here, and we do account for that outlier out there.